All right, so here's how we're going to define our modification of the reward function in this case of what we're going to call potential-based shaping. The potential is going to be defined by this function psi, is it?
Let's go with psi.
All right, so anyway, here's the idea. So once again, here's our Q function defined in terms of a reward function. And I did mess with this a little bit because I now made rewards dependent on the state that we end up in as well, because that's going to be helpful for keeping track of how rewards are changing.
Wait, does that change anything? That doesn't change anything, right? Does it?
It doesn't change anything in this Q function, no. So it's the reward plus the discounted value of the next state, and we average that over all possible next states weighted by the transition probability of ending up in that next state. So that's all the same. If we actually have a reward function that's not defined in terms of S prime, that's fine. This is just helpful for the notation. It doesn't actually change anything if we ignore S prime in the definition of RSA.
Oh, and in fact, if RSA doesn't depend on S prime, then you're just doing a convex sum over RSA, so you'll end up with RSA. So you'll get back what you were before.
Exactly right. So this R, that's right. The reward function pops back out, which is sort of the opposite of what we just did, which is we shoved it in there.
Okay.
Good. All right. And so now our new reward function, R prime, that we're going to use is going to be the old reward function for state action pair minus the potential of the state that we're leaving plus the discounted potential of the state that we're entering. So this difference here between the potential of the state that we end up in and the potential of the state that we left is the bonus that we get, the amount that we're getting warmer, and we're getting closer to good.
Okay. So looking at it, okay, so I see. So let me make certain I got the intuition here. So let's ignore the minus psi of S and just think about the plus gamma psi of S prime. You're saying that every time we enter into some state, S prime, we're going to get that little bonus, which is what we've been talking about before. But now I got to account for the minus psi of S. Well, the minus psi of S is just a way of saying, yeah, but whenever I leave a state, I have to lose that bonus. And that's your way of avoiding those kind of suboptimal positive loops.
Yeah, exactly right. It's sort of like I don't know, good bookkeeping or accounting, right? It's we have to make sure that sure, we made a transition from state S to S prime. We get this advantage of being in S prime, but we have to have lost the advantage of having been in S because we're not there anymore.
Hmm. Okay, so this makes sense.
Great. Okay, so what we need to do now is figure out what does the new Q function look like when we've made these revisions to the rewards as a function of the old Q function.
Okay. I think I know the answer.
All right. So you think you're ready for a quiz, or do you need any kind of additional explanation of what I'm asking?
No, I think I know. You defined. We know what Q of SA is. We're going to change the way the reward function works to have these potentials, and so that's going to change what Q of SA is. It's going to be now called Q prime of SA, and you want to know if there's some nice way that we can describe Q prime of SA. I guess in terms of the old Q of S of A.
That's right. That's right. And in fact, there is a nice way of explaining it, or not of explaining it, but of defining Q prime in terms of Q.
Okay, I think I know the answer. We'll see.